Welcome to Stay Sharp in Digital Engineering, where we uncover the tools, trends, and tactics shaping the digital transformation of products in manufacturing. In this episode of Stay Sharp, my co-host Jonathan Scott and I dive into the evolving world of shipbuilding and its shift to digital tools. Joining us is our colleague Pat Coulehan, who brings firsthand insights from his experience on a 5-year shipbuilding project. We explore parallels with industries like aerospace and construction, discuss challenges like supply chain management and tech adoption, and emphasize the critical role of testing, certification, and cultural change. Let's dive in. Welcome back, everybody, to Stay Sharp, our podcast about all things digital related to products, engineering, manufacturing, service, and beyond. I'm one of your hosts today. I'm Julianne Grant, and I'm joined today with my co-host and favorite colleague, Jonathan Scott.
Hey, everybody.
Hey. And today we're talking about shipbuilding, which is going to be an interesting conversation because there are many challenges going on there as this industry is facing a lot of moves into the digital space. And we're pleased to have a special guest with us today who is particularly experienced in this area. And we welcome Pat Coulehan. Hey, Pat.
Thanks.
Pat's one of our colleagues here at Razor Leaf. He works at our Razor Leaf government business and primarily works with the government projects and government clients. And Pat's worked with numerous CAD and PLM systems from many vendors over his 30-year career in digital engineering. And so today, Jonathan and I invited Pat to come and share his experiences and talk a little bit about some work he's done with a large U.S. shipbuilder and helping them transition to their digital programs with tool sets and advancing their digital capabilities. So Pat's been doing this for, 5 years now?
Yeah, I spent about 5 years on the one project, at least, one of the larger ones.
Great. So we look forward to hearing your insights. Welcome, Pat.
Thanks.
Yeah, it's funny. I wanted to just add, I think, Pat, you and I, over the course of our careers, because we haven't worked for 30 years together, right? You've worked places, I've worked places, but I think almost every time we've bumped into each other, when we weren't working in the same place, it had something to do with the Navy.
Yeah, pretty much.
Anyway, it's fun that we're talking about this topic. But yeah, with that, let's dig in. I'm really excited to talk about this. Like you said, Julianne, shipbuilding is one of those industries that I think is right on the precipice of a lot of this digital stuff, right? I mean, they've been doing digital stuff for a while, so it's not like digital's new to them. But there are so many things coming and technologies that people are saying, okay, this is how we're going to apply that there, that I think there's a lot still coming for them, right? Where some industries are further on a curve, they're getting some benefits. I don't know. It seems like there's a lot interesting. So I don't know. I think it is also an interesting topic because so many things about shipbuilding are unique. You're making something really huge. You're making a couple, you're making more than one probably, but you're not making as many as you do if you're making, cell phones or tractors or cars or trains or whatever it might be. And the thing is going to last forever. not literally, but a long, long time. And that's an interesting aspect when you're making a product. And when you're making few of them and each one's unique, it's also challenging. So, there's lots of things. We should dig into it, but I'm glad we're talking about the topic. And Pat, I know your experience doing a very large project there brings a lot of knowledge there. And let me just jump in with a question. So I was talking about industry there for a minute. What do you think makes shipbuilding similar to other industries? I've got some thoughts on this, but I'm curious, when you were in it, what did you see that made you think, it kind of reminds me of this, or, I see similarities?
Well, there's actually similarities to a lot of different industries. That's one of the problems with shipbuilding is because there's a lot of, you have people doing HVAC, you have people doing piping, you have people doing structures, you have people that are doing.
It sounds like you're talking about a building right now, right?
Possibly run into, right? So you have similarities to aviation because you have small quantities sometimes of things that are very configured. You have just a lot of different similarities to different industries, so you have to be able to kind of master them all to some extent.
Yeah, it's funny, as you were making that list a second ago, it sounds like you're talking about buildings, right? But you're talking about a ship.
Right, it's closer to AEC than it is to mechanical most of the time. There's obviously mechanical aspects of it, there's electrical aspects of it, there's piping aspects, all kinds of things. Because you have to make something
like a mini city, right?
Floats, but you also have to make something that people can live in, right?
Yeah.
Yeah, like a mini city, exactly. It's like all these things are happening.
Yeah.
Now, you mentioned a similarity to aerospace and configuration. Let's double click on that for a minute. What do you mean there for the audience that maybe isn't as familiar with configurable products and that kind of thing? Just dig in there.
When you think about, you're talking fairly low quantities of a lot of these things, and also like you mentioned, if you're planning to have this thing in service for 50 years, you need to be able to know what's different about this one than the last one that you rolled off there isn't really a line, right? It's so you,
right.
you basically, okay, well, I have one I produced this year, and I'll see how many I can get out. And then, depending on what you're making, it could be you're making a few a year, you're making one every 3 years or something, right? So I mean, it's a pretty low volume, but you're always going to learn things as you go along and create the first one and make changes. So you're not going to have the first one looking like the second one that comes off the line, and need to be able to manage the configurations and effectivities like you would in the aerospace world.
Yeah, right. Because it's not that it's necessarily a revision to things, right? Like it's really a configuration change. Hey, I learned this. Therefore I designed this differently. I have to maintain the design of the first one I made, but I need to know how they're different.
Yep. And you need to be able to have that traceability that says this is what the first one looked like. And then do I want to go back and do an upgrade on this other one because I did it on the the fifth one I built, right?
Right. Yeah. All right. That makes sense. I think it's good touching on that similarity because you're right. I mean, aircraft, certainly they have that same challenge. There's another thing that jumps out at me when I think about the similarities. There are some industries where design chains, supply chains are not a big deal. They just, I don't want to say companies are fully vertically integrated. It's not that. It's just, it's not as big a part of how they operate. Right. But for me, shipbuilding seems like one of those that, supply chain is a big deal. I mean, what's your view?
Yeah, especially because you have a lot of suppliers that might be local shops that are, located close to a shipyard and doing things that, working with drawings that they've been doing for years. So you try and give them some 3D and they're not necessarily as capable of that, or they're used to, rolling out a 12-foot drawing of something and with a bunch of heating, ventilation ducts on it and stuff and manufacturing it from something like that. And then all of a sudden you want to use 3D tools and sheet metal and other types of capabilities that you're used to. And that just means that your suppliers have to come along with you on the process.
That certainly sounds like another aerospace similarity, right? I mean, that's what a lot of those guys had to deal with is go get your shops educated and turned on to new tools and new ways of working so they could get them the parts they needed.
And you've got guys that are doing welding and, there's just, the scale is just so much bigger too. So,
Well, that's a perfect lead into the opposite question, I guess, which is, okay, what makes shipbuilding unique, right? What makes it not like other industries that people may not even realize?
Yeah, I think more the AEC aspect of it, like I said, that you have to have, and even regulatory compliance and things like that, right? So you have to worry about, what kind of fire suppression systems do I have? What kind of, all these other things that are more like you would have in a building than you would in an airplane. Obviously, you have some of that in airplanes as well, but things like that you have to think about livability. You're not going to be on it for a matter of a few hours like an airplane. You're going to be potentially living on that thing for, months. Yeah.
No, it does
and
probably present some interesting challenges.
I mean, obviously, you have propulsion as a whole other domain that you have to worry about.
Yeah, that's interesting. You draw a lot of similarities. To your point, it's different because of how it has similarities, but not total, right? It's so like an airplane, but like a building. Okay, that's pretty different in terms of what's at the cross section between those two. It
kind of has both challenges because with a building, you're only making one usually. Although I guess that wouldn't be totally true if you're designing something that's a chain or something,
right?
But yeah, you have to have some pretty large amount of data that you have to deal with. It just isn't always easy to work with. And if you have different domains and different tools and lots of niche tools as well that you use, then you have to manage data from a lot of niche tools that and pass that data along to other people with using other niche tools.
Tools and tools and tools and tools. You said something initially when we were talking about manufacturing these things that also jumps out at me as pretty unique when you're talking about supply chains and machine shops nearby. I mean, shipbuilding is one of those industries where there is no assembly line, right? I mean, you're dealing with maybe some buildings, maybe some yards, but big stuff moving around. And like you said, shops, suppliers, you might need them to be nearby because of the size of what you're dealing with.
Right, and you have to have some pretty large equipment and plan for, assembly processes and things like that. So the manufacturing process planning gets pretty intense because you have to have a crane that's big enough to move around a big piece of metal, that's got to be positioned somewhere, and you got to be able to do it safely. And so simulating the manufacturing process and making sure that you're able to put things together. You also have to think about things like when you put wiring in, you don't put it in one end and try and pull it all the way through. You have to start in the middle and, pull it from both ends because you're not going to be able to get it that far, right? Things like that.
Right. All these things that you wouldn't think about in other contexts, but as you're putting something that large together, you need to think of.
And I was going to say, I imagine that they must have to use some level of additive manufacturing for parts replacements and things like that. I mean, especially when they're out at sea once they're launched. So,
yeah, and a lot of scheduled maintenance too. You have to bring them back into the shipyard to, it can take a long time to have scheduled maintenance to replace things. So, preventative stuff is important too, predicting what's going to go wrong and what you need to service. So that's really where the digital side is. The intention is to save a lot of money in the sustainment side. You don't really save the money up front in the design or even the initial manufacturing. It's just after years and years of running this thing, you're going to save money because you're going to be able to have lower maintenance costs.
Well, and certainly, I mean, to the point that you're both making, if there's any kind of maintenance or repair that you can do while you're out at sea, you're saving everybody time and money, right? I mean, if you can do repairs without having to come in for a maintenance availability, that's tremendous. And
of course, the amount of crew that you need to staff it too is a huge factor in the cost as well, right? And how much that cost is over the years. So if you have something that's more automated or something that can be run by a smaller crew, that saves you a lot of money in the longer run.
Well, you touched on something a minute ago, Pat, when you were saying, tools on top of tools and sharing data in different formats, those kinds of things. This is where you spent a lot of time dealing with some of those tools and digital and that kind of thing. What are the biggest challenges that shipyards and shipbuilders face and run into as they're transitioning to digital, as they're doing digital design work on ships and things like that? What did you see? And what do you think they're challenged with?
It might not be in all cases, but what I ran into the most was probably the fact that we just didn't have that everything becomes a standard part, right? If you want to buy, they always used to make fun of you have to have the $700 mil-spec hammer or the toilet seat that costs $1,000, right? But somebody has to go out there and figure out what one you're going to buy and have a model of it that you can put in there. And by the time you go through all that, that's what adds up all the costs, right? That's the problem, that you don't have a catalog that you can just go out and go off a commercial site and say, I want one of those, and pull down a CAD model. And anybody that's doing the engineering work has to go to the catalog team to say, go find me this. And then they have to add it to standard catalog and wait till it's in the catalog. Then they can instance it in. You need all the attributes on that part that say, how much does it weigh? What's the density? Where's the center of gravity? You need these things, especially on a ship, right? You need to worry about, all the material properties and the basically the weights and then what if you're on a military ship, you have shock testing too, right? Is it going to rattle loose because a bomb went off outside the hull somewhere, right? There's things like that are a little bit unique.
Well, and you mentioned regulatory. It just made me think of requirements that are unique, right? Like you said, shock testing. Like, okay, that might only be in defense, but that's one of those unique things when you're building a ship. You probably got other things, corrosion, materials things, like you said, weight, balance, stuff like that.
Weight and balance is obviously, huge. And then trying to figure out, the propulsion, how much, what kind of engine capacity do you need to order to get the performance you need, and of course, obviously, the suppliers for the engines. In that sense, I think it's probably more similar to aerospace, right? Because you've got different aircraft engine manufacturers that work with the airframe people. So it's not like the shipbuilders are doing all the engine design necessarily themselves. Right. But you still need models of that. You still need to know, how that's going to impact your weight and balance and performance and everything.
That's probably another similarity back to aerospace in terms of there's some element of its systems integration. You're buying something off the shelf from somebody, standard parts, whatever it might be, but there's an element of, well, they've never put it in this ship before. So
Right.
I imagine that's a lot of the work that goes on.
Yep. And then, trying to figure out, say, also you have standards for pretty much everything. Even when you talk about, setting up any new tool, you have to figure out if you're going digital with something, what are my standards? What are the, if I have somebody that's designing sheet metal or a hull, what's the list of values that I want somebody to have available to them? I have that on a chart somewhere. I got to make sure I put that into my system so that my system reflects what my actual standards are. So all that setup gets to be a huge hurdle when moving to more of a digital world.
Well, and this is something that I'm curious about. I see this in a couple of different industries, but I want to know what you saw in shipbuilding. Is the time scale then, because like you're saying, there's a lot of setup to setting up catalogs, standard parts, things like that. But the software tools, the digital tools change, at a pretty quick pace. They're changing every year, sometimes multiple times a year, that sort of thing. How do those two interplay? I mean, what do people do when it's like you're getting new tools with new capabilities, but you're still designing the same ship and you set up the catalog 3 years ago?
Well, yeah, that's part of the problem. That's one, making a transition between the one that I was working on for 5 years. That was because they had started the design years before in another system that was now basically out of date. So now we're in the middle of designing something that's think of it as like, 75% of it's already there, but we need to finish the last 25% in a different system altogether. And so doing the migration live while people are still moving was pretty much my biggest nightmare. Trying to get set up for that. Yeah.
This is what experience is. It's what you get when you don't get what you want.
Right. And it's like by the time you're done, you're using completely different tools than what you started with. Right.
Right. That strikes me as one of the big challenges because of the life of these products. Like you said, the long life, you want to maintain them for 30 years, 50 years, whatever it might be. The change in the software and the capabilities over time. I mean, were there techniques that you saw that were working or that were not working, things that people would be interested to hear?
To some extent, it's like everything else with new technology. You still have to go through the cultural, retraining people to think a different way and do things a different way as you're going. So that becomes a big part of the hurdle as well. But the technology, you just have to you have to do things incrementally, right? You can't just say, tomorrow we're turning a switch and we're going to do this. You have to roll in one domain at a time or one set of data at a time, and you just can't pull a switch and expect everybody to turn immediately, right? It's just like a ship, you're not going to spin if you're depending on how fast you're going, right? You gotta pretty much be careful about planning out what your moves are.
Yeah, that makes sense, right? With as many domains as you mentioned earlier, that's like, what is it, the n squared minus 1 problem or whatever that math is about the number of interfaces you have. The more domains, the more interfaces, the slower you need to go to let everybody adjust when one domain says, hey, I'm going to use this new feature-based thing. Everybody else is like, I don't know how to use that. It's going to take a bit for me to get used to it.
And you also have to plan that for your product, right? So that your product is more modular or more upgradable and more, right? So that the ship itself doesn't stagnate because everything's technology right now. You have to, that's why we talk about systems engineering and other things and using more out of the box components and more upgradable software and things like that because that just takes a long or that can really cause a problem if you can't keep up to date.
One of the things that you mentioned, even before I asked that question about challenges, that I think is one to dig into for a minute, is the idea that you might go digital or model-based or some kind of advanced technology inside the shipbuilder, but the machine shops that you work with, the suppliers you work with, whoever it may not be ready for that. What have you seen there? Do people, how do they deal with it? Do they deal with it well?
You get different approaches. I mean, you still have okay, we're going to be all model based, but we still have to be able to produce the same drawings that we produced before, and so they're not in a sense trying to force it down onto the supplier base, but it depends on the approach of the manufacturer. If they want to push that down, they're going to have to train, put those requirements down on the supply chain and train them on how to use it and provide them the tools and the methods and things to do it.
Yeah, either way, I guess it's an investment
process.
Yep. Either way, I guess
we
it's an
saw
investment.
that years ago with when model-based, with Boeing and pushing all these suppliers to buy a seat of Innovia or CATIA or something just so they could view tolerancing information, right?
Right. Okay. Well, what did we miss? When you think about some of the challenges that you helped overcome or had to deal with while you guys were doing this project, I mean, is there anything that we didn't talk about that we should, let people hear?
I think we didn't really talk as much maybe on the data management side of it, that, when you talk specifically about PLM, and managing that amount of data and that amount of configuration, that was also just one of the bigger challenges, right? Making sure it's not just visualization, but it's also, managing configurations and attributes on parts, right? So you have a lot of custom attributes, a lot of custom object types, things like that. Right? You can imagine as with AEC that you have a different set of attributes on each type of object that you might want in there. So it's not just everything's the same. It's much more of a much more different types of object types, right? This is structural hulls versus this is an elbow, right, on a pipe.
Right. Or a microwave in the kitchen or a whatever, yeah.
Right. So you have equipment, you have systems, you have all kinds of different types of data you want to manage, and you want to be able to see all that within PLM too. So they really wanted to expose a lot of those attributes and manage a lot of those attributes, not just on the reference level, but on the instance, right? When I push it into this location, what zone is it in? And, now you have to worry more about location specific attributes.
There we get into a really interesting one, right? And I was hoping we'd get into some things in the conversation today that really are that kind of detail. So I'm going to take a step back, and for the audience that may not be aware of it, right? So what I hear you talking about, Pat, is, you could say, let's say we're talking about a huge ship and there's like 4 kitchens in it. You could say we got a microwave and you track the attributes for it, but it turns out that the microwave that's in the fore kitchen is different than the microwave in the aft kitchen, and you need to account for that. And you need to deal with the different attribution, and that can be a challenge in terms of how you track everything.
Right. And because you need to be able to keep track of those attributes and call them up in the context of whatever assembly they are, right? And when you want to look at something, you can't just necessarily load. Do I want to load the whole system so that you see it going throughout the ship, or do you want to load a compartment, right? This is what I have within this area, or where do I have a hole that I can put something through? I need to plan for locations where things are going to go through bulkheads, right? So you need to be able to, that spatial aspect of it matters as well.
This is where the digital tools are essential, right? It's like very hard to do that in the traditional world, document-based world, but with databases and digital, you can start to call those things up and filter and search and that kind of thing.
Right, especially when you have people that are working on their own domains, they don't necessarily have visibility to the rest of the ship. They see the piece that they're working on, and then all of a sudden, you can't put that there because the microwave is going to give off RF that's going to interfere with some other signal somewhere else, right? So you have more specific types of analysis that you might have to worry about, and more things that you have to have the whole surrounding context when you do that work.
Makes sense. So anything else? I mean, I feel like that was a good one that would really digging into some of the challenges of managing that data and how you deal with it. But anything else?
Yeah, I think, and maybe, following through the manufacturing, but like I said, that the testing and certifications and making sure that things perform the way they do and tracing that back. I guess that's pretty much every industry now too, as well. But but their physical testing on a ship is a little bit more expensive than it could be on some other products. So again, that's where you'd like to see the digital benefits helping with the costs and other things down the road. It's always the down the road stuff that you don't think about that's adding to those costs, and whether you can simulate things properly when you do the design is a really key.
Yeah, and I imagine, to your point, that you had the right data from when you did the design so that in 10 years, can you simulate what you need to know that the retrofit's going to work, to know that, there's not a problem or whatever it might be.
Right.
Okay. Well, I won't keep asking, is there anything else? Is there anything else? But those are good. I'm glad we dug into those. I think this was a really interesting conversation. No, go ahead, Julianne.
Yeah. So I was kind of curious. So, these, as you said, these projects last years and years. And, when we talk about other, digital projects, people are usually a big hurdle and that kind of a thing. So what are some of the hurdles for success for shipbuilders that, even though it's a 5-10 year project, like how do they keep, chugging forward, making sure they hit their goals and deadlines and things like that? What are the things that get in the way?
So I felt like I was kind of getting in the way because I was a technology guy, right? That's putting new technology and delaying things for them, right? So they're pretty rigid on schedule. They can get pretty intense on. We can't be impacting schedule because a delay can obviously delays can happen. Delays do happen, but
things are done in a certain sequence, obviously. So you don't have to have. You can start building the hull while you're still finalizing designs on other things, but you do still have to make sure you're sequencing things, that you're not getting ahead of yourself, right? You don't want to have it sitting there while waiting for something. So just sequencing things is a key there with any of the engineering and manufacturing process planning pieces of it.
So, just, I guess, wrapping up the whole conversation, if I was to summarize, unless Julianne, if you want to take a shot at it, you're welcome to.
No, you can do that.
Okay. I think what I take away from a lot of this, Pat, is in terms of what shipbuilding is it has some similarities to a couple of industries, but it's really not like any one of them, right? So we talked a lot about aerospace and we talked a lot about AEC and building, right? And so it makes sense. You're kind of in between in terms of volume. Buildings, large buildings, you're only making one, maybe two. An aircraft, you're making still low volume. Maybe it's 100, maybe it's a couple hundred, maybe it's a couple thousand. But ships are right there in the middle. You're making 5, you're making 10, you're making 20. Maybe only 3 or 4. And that makes it that kind of in-betweener in some ways, where it's a little bit like buildings and rooms and living quarters and all those sorts of things, but it's a little bit like aircraft in terms of regulation and safety and weight and balance and all these things that come up, right? Configuration, you mentioned. So I think it's interesting, and I guess that means that it shares a lot of the challenges that we've seen in some of those industries. I love some of the ones you brought up there about like life of the design program, life of the product, and what does that mean for technology, right? Like what people are doing and what they have to deal with over the course of the program. I don't know. There's probably other things I missed. What else do you think, Pat, in terms of the highlights that we talked through that people should take away about shipbuilding?
There are a lot of specialties involved, and of course, because of that, you're going to have certain people that understand one aspect of it, and certain people that understand that another aspect of it. And kind of, since we're the technology in the middle, we have to bridge that. Like you said, you have the hardest challenges of aerospace and the hardest challenges of AEC, and kind of everything all mixed together, right? So that's sort of my role in there, as I'm crossing a lot of domains when I do work with people in the industry. So I have to be able to talk to a lot of different people about a lot of different things.
Yeah. Okay. Well, I think this has been great, Pat. I enjoyed the conversation. I'm glad we dug into this. This is something that, we deal with at Razor Leaf, right? I mean, we have customers who are shipbuilders, but, getting into it for that broader audience so they can kind of get a peek into what makes a certain industry unique and interesting was really helpful. I enjoyed that a lot.
So wrapping things up, I want to thank Pat for our conversation today. That was interesting from my perspective too, hearing a little bit about all the big challenges around managing a massive project like shipbuilding. That is, it's a city in itself, and there's a lot of different things happening. So God bless us. Work on ships. But One of the things you kind of mentioned that we didn't really dive into that I think we want to come back on and talk about is model-based systems engineering. I think you had mentioned something about that and some of the things that you have to do in your shipbuilding processes. But would you be open to having another conversation about that with us? I think, that's an area we've been talking about, but we really want to do a little bit of a deeper dive, I think. Right, Jonathan? Yeah,
I think that would be great if you'd be willing to, Pat. I know that's something you deal with these days. You spend some time in that space.
Great.
Awesome. Well, we'll plan to have you back and talking about MBSE. And as always, there's a lot of ways we can talk about these topics here on the podcast, and we welcome everyone's input. So if anyone has any questions or anything they want to talk about or has a topic they'd like us to explore, please be sure to make a comment on one of our posts, or just like one of our posts if you enjoy the conversation. We always appreciate any sort of interactions and engagements from our audience. This podcast is for you. So with that, I want to thank Pat for participating today. And I also want to thank my co-host, Jonathan.
Absolutely.
And with that, we're going to close off another episode. Thanks, everybody. Thank you for being here and listening to this episode of Stay Sharp in Digital Engineering with Razorleaf. If you have any questions, please leave us a comment on our post or send us an email to podcast@razorleaf.com. We love hearing from you. And if you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite platform or on our YouTube channel. Until next time, stay sharp.